All right, let's talk about forces. Forces are pushers or pulls that comes from interactions of objects. So here, if the car stops driving, which ones would go away? Obviously, the driving force would go away. Air resistance, because it's not moving, would also go away. And friction would actually change. So right now we have, as we'll learn more about tomorrow, more what we call kinetic friction, and there's static friction. But weight would stay, the reaction force or normal force would stay, and friction would just change. So if it jumps the river, what would go away? The reaction force would go away because there's nothing pushing up like the ground. Driving force would go away because the car isn't accelerating anymore, and friction would go away. We have two types of forces: contact forces, which are the ones that are a result of two touching objects, and action at a distance are those that are not in physical contact. So contact is touching at a distance. They can be touching, like gravity still impacting you whether you're on the ground or not. What they have in common, their forces, their interactions, and they cause changes in motion. We measure forces in newtons. Newtons is the force required to move 1 kilogram of mass with the acceleration of 1 meters per second squared. We show forces with vectors, which are arrows with a magnitude and a direction. So this is a magnitude, this is a magnitude and a direction. Okay, so larger arrows means larger forces. Over here, this force diagram or free body diagram is balanced because I have 20 up and 20 down. There's no motion. Unbalanced, notice I have motion. I have 20 up and 20 down still, but friction is going left, which means in order for the body to be moving right, I have to show a bigger arrow since it is not moving. And that's it. Let me know if you have questions. Bye.